me go ahead and record and share my screen. Un momento. Okay, thumbs up. You can see this hopefully for me. Cool. All right. Yes. Okay. All right. This may not have been your question number one. So I'm just putting these question number one, whatever, as we go through these. This may not have been your question number one. So just be aware of that. This is a very common question. And it looks like something, and it should remind you of something. And so this kind of a question I actually see on just about every single AP exam that I've given, that I've taken, each year in May, this kind of a question pops up, and it's often one of the most missed, even though it's pretty simple. So this is a good one to know how to do. What this should remind you of is the definition of the derivative. That's what this looks like, right? Our definition of the derivative says, if I'm trying to find f prime of x, I would do the limit as h approaches 0 of f of x plus h minus f of x all over h. That is what the definition of the derivative is. Now we know if I had a function, like let's say f of x was x cubed or something like that, then we would have the limit of, as h goes to 0, of x plus h cubed minus x cubed all over h. Right? That's like what we would do if our function was x cubed. But we know other methods to take the definition of the derivative. So like if I saw this and I could recognize, oh, all they're asking for is the derivative of x cubed, I would know, well, the thing I'm trying to find is f prime of x, and I can use power rule, for example, and get 3x squared. So they're not expecting you to actually use the definition of the derivative here. What they're expecting you to do is recognize that that's what the question is. So the function on this one that we're asked to find here, our function f of x would be what?
Cosine of x.
Cosine of x. And since all it's asking us to do is find the derivative of cosine of x, then our derivative would be equal to what?
Negative sine x.
Negative sine x. And that's all you have to do. There's really no work involved on this question. It's just recognizing that this is definition of the derivative. Let me give you a slightly similar example, and I would write this one down as well. Let's say instead of that, they gave us the limit as h approaches 0. This is kind of the other variation of this question, of cosine of pi over 2 plus h minus cosine of pi over 2 right here, and then all over h. This question, what a lot of people would assume is that it's asking you to, if f of x is equal to cosine of pi over 2, they think that that means find the derivative of that, which is not the case. That's not what this question is actually asking us for. This question is still giving us the function cosine of x, but it's asking us to find f prime specifically of a value. So instead of f prime of x, it's asking us to find f prime of pi over 2. You'll notice the x's have been replaced with that. Okay, so we don't plug in the pi over 2 first. We first would take the derivative, and then we would plug in the pi over 2, right? So we would need f prime of x, which we know we just said is negative sine x. And then you would be evaluating it at pi over 2. So pi over 2 is up here, sine is the y coordinate, that gives us 1. It's negative sine of pi over 2, that would be negative 1. And again, you're not really doing anything to that fraction. You're not trying to distribute cosine or use any of those trig identities or anything like that. You're just recognizing the question is definition of the derivative. Okay, any questions on that one? Or the first one? Holler if you have a question, just unmute and go. Okay, I'm gonna run through these somewhat quickly just to give us as much time as possible. Okay, this question says, this was a highly missed question. And there's some algebra involved in this problem that I think a lot of you got stuck on, so I really wanna go through it. It says a particle starts at time t equals 0 and moves along a number line so that its position, make sure we're reading this carefully, its position at time t is greater than or equal to 0 is given by x of t equals t minus 2 cubed times t minus 6. The particle is moving to the right 4. And then it gives us some time options. I just removed the multiple choice here because we can figure this out without the multiple choice options. Okay, quick question that we should think about before we literally do anything. One, in what circumstance would a particle be moving to the right?
Would it be when velocity is positive?
You're exactly right. When the velocity is positive, that's what we're looking for. Okay, if the velocity is positive, that tells me I'm moving to the right. If the velocity is negative, that tells me I'm moving to the left. Okay, that's what it is. If position is positive, that just tells me I'm over here on the right side. It doesn't tell me where I'm moving, right? So position being positive just tells me where I am. It doesn't tell me the direction that I'm moving. Velocity being positive means I'm moving to the right. Okay, so what we need to find is we need to find velocity. We're given position, so we need to take a derivative. Well, our derivative function, x of t, equals t minus 2 cubed, times t minus 6. We're going to need product rule for this. Okay, and technically chain rule. The derivative of the inside function happens to be 1, but we are technically using chain rule. So we're going to set up our a, our b, our a prime, and our b prime. A is t minus 2 cubed. B is t minus 6. I would be writing this down. We get 3 times t minus 2 squared, technically times the derivative of the inside function, which is times 1. Just be careful there. If it was like 2t minus 2, you'd have a times 2, right? There is chain rule. It's just the derivative is 1 inside of there. And then our b prime is 1. A lot of you got to this step if you understood that what you were looking for was the velocity being positive. Some of you just graphed x of t and you figured out where x of t was positive and then got a wrong answer here. Okay, so we do need to actually figure out our v of t. So v of t, which is the same as x prime of t, you can call it either one, is going to be our a times our b prime. So t minus 2 cubed times 1. I'm not going to really write the times 1, but we are doing times 1. And then remember, for product rule, it's a plus. So plus 3 times t minus 2 squared times t minus 6. This is where a lot of you got stuck and you were just like, I have no idea how to think about this graph. I don't know what to do from here. The AP exam actually loves to give questions that come in this form because you can factor it, but it's just not super obvious how. Like when you guys are learning how to factor, you don't often see questions like this, okay? For factoring, if we're looking for our greatest common factor, we're looking at the thing I can divide out of this first term and divide out of that second term. Well, the biggest thing that those have in common is that t minus 2, but only to the squared power, right? Because I've got a t minus 2 cubed in the first one, and then I've got a t minus 2 squared in the second one. So essentially what we're doing is we're dividing that out. That's what factoring is. Okay, what I would have left from that first term is a t minus 2. And then what I would have left from that second term, we don't have this t minus 2 squared anymore. We've already divided that out. So we would have plus 3 times t minus 6. That's what we would have left in that second term. I'm going to simplify that. We don't really need a whole extra step for that. 3 times parentheses t minus 6 is plus 3t minus 18. Okay, now we're almost to a very helpful place where this is factored and we can think about the graph. So t minus 2 squared times, we've got a t plus a 3t, that's a 4t, minus a 20. I'm going to factor out a 4 just so I can easily see that factor. So times 4 times t minus 5. Whatever order you write that in is fine if you want to put the 4 in front. Okay, now is where we come back to our graphing. Remember our multiplicity of zeros. We've got this 0 being squared. So at that 0, it's going to bounce off of the x-axis. It's not going to go through. Remember that I think it's very helpful to start from the right-hand side. So we've got 2 zeros, 1 at 2, 1 at 5. Our leading coefficient is technically this 4, right? So I would have like a 4t cubed, I think, out of this guy if I multiplied everything out. So that means the right side is going up. When I get to 5, since 5 is only raised to the first power, I only have 1 0 there, my multiplicity is odd, meaning I go through that 0. And then when I get to 2, my multiplicity is even. I've got 2 zeros at that point. It's going to bounce off. This is my velocity graph. Doesn't have to be perfect. What we're trying to figure out, hey, where's this graph positive? That's all I'm looking for. Where's that graph positive? That graph is positive when t is greater than 5 for that portion. And that would have been the answer here. When t is greater than 5, that's when our particle is moving to the right. When is our particle stopped? If I were to ask you that, when is our particle stopped?
When v of t equals 0.
When v of t equals 0, where does that happen, Charlie?
Like on the velocity graph?
Well, I don't know. I'm asking you. At what time?
Oh, at t equals 0. No, wait, no, it doesn't. No.
Augie, did you have an answer?
Yeah, t is 2 and 5.
Yeah, at 2 and 5, because it's where our velocity equals 0. So, right, if I were to ask you where's the particle stopped, it would happen at 2 and 5. That would be where the velocity is 0. If I asked you where the particle is going to the left, it would be all of that time when it's below the x-axis, right? If I said where does the particle change direction, that would only happen at 5, right? So there's all types of different ways I can ask questions about all of this information. You just got to be careful and know what you're looking for. Any questions on this one? Again, I think this one's hard literally for algebraic reasons, not for calculus reasons. I think the algebra is where we're like, oh, I just don't know how to factor this or think about it. Okay, or I don't know how to graph it, which is really just algebra and honors pre-calc. Okay, questions here?
Will we, like, did all of us necessarily have this question? Like,
Yes.
okay.
On this test, that's how that worked. Okay, but not necessarily in the same order. And I think you would have had exactly these numbers. So I'm pretty sure. Okay, some of you may not have gotten to this. It might have been the last one for you. Okay, all right. Let's go on. Oh boy. Man, oh man. You know what? I put U sub on here and I think we're gonna get it. We're gonna do the U sub. We're gonna figure it out. And then, oh man, we can't. We hate it. Got to get better at that U sub, guys. It's all over the test, I promise you. So go ahead and write this one down. We have an integral from pi over 4 to pi over 3. This also has trig and other things that you guys don't like. It's like a conglomerate of your least favorite things in calculus. Okay, so we have secant squared over tangent x dx. Remember, this would require u sub for a couple reasons. If I were to try to take the derivative of secant squared over tangent x, I have quotient rule and I have chain rule. So that tells me for sure I'm going to need u sub if I'm doing the antiderivative. Okay, some of you, I think, tried to simplify this. You tried to rewrite it. It's actually written in a really helpful way right now because since I know I need some u sub, I'm looking for the derivative and, a function whose derivative is available, right? So I got to know my trig derivatives. That's really important. But I know that if I picked u is equal to tangent x, the derivative of that du is secant squared x. And then don't forget your dx, right? That's differential form. It's the same as writing du over dx is equal to secant squared x, but we just prefer to write it in our differential form, secant squared x dx. Okay, that's everything in the equation. So I'm going to rewrite this. I'm going to come back and change my bounds. Many of you are still forgetting this step or going back and trying to do it another way. I want you to be successful. This is the faster way to do it, and you're going to need to know this for the test. Okay, we're going to be able to rewrite this. So we have really 1 over tangent x times secant squared x dx. Like that's another way you could have written what is inside of that integral, which means we're really going to have here 1 over u du. Let's go through and change our bounds. This is also where some of you struggle. Okay, we need to know what tangent of pi over 3 is. That's going to be our top bound. And we need to know what tangent of pi over 4 is. That's going to be our bottom bound. Because all we're doing is plugging these bounds into our relationship between u and x. So my relationship between u and x is that u is equal to tangent x. So in order to find my u bounds, I need to plug in my x boundaries into that equation. Okay, these are values you should know from your unit circle. It's very important. Tangent of pi over 4, I think, is the easier one, because if you recognize that tangent just means slope, that's all that the tangent is. It's your sine over your cosine, which is your y over your x, or your rise over your run. We know on that coordinate at pi over 4, we have rad 2 over 2 and rad 2 over 2. The rise is equal to the run. So I get tangent of pi over 4 is equal to 1. Perfect slope of 1 in that first quadrant for tangent of pi over 4. Okay, tangent of pi over 3 is a slightly harder one. There's a couple weird values there, especially our pi over 6 and our pi over 3 reference angles. We've got essentially a rad 3 over 3 or a rad 3. Our slope is steeper. At tangent of pi over 3, we end up getting rad 3. Or if you know your coordinates there, then you can use your y over x or sine over cosine to evaluate that. Okay, so now my bounds are 1 and rad 3. We're going to update that. We're not going to skip it. We're not going to try to go back to tangent x later and go back to those pi over 3s and pi over 4s. We're just moving on with this equation. Okay, from here, if you tried to do the power rule for integrals, you would have u to the negative 1. If you added 1 to that and divided by that value, you'd get u to the 0 divided by 0, which should tell you that 1 over u, the integral of that, is actually what?
Well, ln u.
Ln of
Absolute value.
absolute value of u. Perfect. Okay, don't forget your absolute values here. It's not going to matter because both our bounds are positive, so it actually doesn't make a difference here. But just for making sure that you guys have that correct, I would always recommend including it. We don't need a plus c because we've got bounds. Anytime you have bounds, you don't need a plus c. You could include it if you want. So now we have ln of the absolute value of rad 3 is rad 3, so you can just write it as rad 3 minus the ln of 1. What is ln of 1? 0. Perfect, Nauman. So it's 0 because the question here, ln of 1, is really e to what power is equal to 1? That's really what the question is asking, right? Because ln of 1 just means log base e of 1. So we're saying e to what power equals 1. The only thing that could be is 0. So since that's 0, our final answer is ln of rad 3. Lots of things to deal with here. Trig, tangent values of trig, not your favorite. U sub, ln, right? Evaluating ln, like simplifying ln. That's a lot of stuff in one question. And it kind of draws on a lot of different topics. It draws on algebra, pre-calc, and calculus. That is an AP style question. Some of you said you wish we had done harder questions kind of throughout the year, which I totally understand. But you got to learn to crawl before you can walk, right? So we have to know how to do all of the basics kind of separately before we can put all of them in one question. If I gave you kind of this stuff as when we were going over U sub, you would have cried, I think, or you would have just like quit. So I need you to make sure, yeah, once we feel comfortable with all the different topics, yeah, you're going to see questions where all of them are together. Again, if the Princeton Review feels very helpful to you, if it feels harder, use it. It's a resource you've got. Okay. There's also the Barron's. If you guys haven't looked up that book is harder than the Princeton Review, just on Amazon. I think it's $10. I have it linked on my syllabus, which is on Canvas at some point. If you look at that, that Barron's practice book is really hard. So if you want even harder practice problems, you can look there. Okay. Any questions on this problem?
Ms. Tosh, I had a question.
Yeah, go ahead.
So because we changed our bounds, that's what we don't substitute in our 10x back in, like in, it's like ln of, because I think that's what I missed. I think I did like ln of 10x, and then I put in my like my little bounds. But so that's the reason why we don't like put the ln. That's the reason why we don't put in the 10. Okay. Yeah.
So if you have bounds, you don't ever go back to this stuff at all, as long as you change your bounds, which you should anyways, because it's wrong if you don't. But yeah, if you change your bounds, you should not be going back to the pi over 3, the pi over 4, or the tangent x. All of that stuff is in the past. Okay, if we have our bounds, this new integral is totally equal to our first integral. So there's no need to look back on any of the other stuff. Great question. Any other questions here? All right, rolling right along. This one looks easier than it is. There's like a little trick here, and they love this same trick. They kind of use it quite frequently. Many of you have the right idea, and you just breeze through this question because you're used to certain things about this question being easy. And then this one is a little bit trickier. Not much, but it's a little bit trickier. So go ahead and write this down. We have an integral from 2 to 4 of f of x dx, which is equal to 6. And then another integral from 2 to 4 of f of x plus 3 dx. We're trying to find what that's equal to. Give me a second to write this down. Again, all these questions are very common. So even if they feel hard, you're going to get used to seeing them. Like once you do a couple more practice tests, you're going to be like, oh, there's that kind of a question again. They're not all the same exact kind of tricks, but they are very similar in their setups. Okay. So we're trying to find this portion of the second integral, the integral from 2 to 4 of f of x dx plus 3. Here's what you should know. If I have an integral that is separated by addition or subtraction, I can break that into two integrals, which is what you should do here. I have the integral from 2 to 4 of f of x dx, plus I have the integral from 2 to 4 of 3 dx. Most of you were just like, well, if the integral from 2 to 4 is 6, and then I add 3, then the new integral is just equal to 9, because all you did was add 3 to that. That's not what the question is asking. It's still asking you to take an integral from 2 to 4 of 3, right? And that's the piece most of you miss. So most of you have the first part, right? Like 6 is equal to that first integral. We know that, we're given that information. But for the second integral, you actually have to take an integral. So the integral of 3 is 3x. And we're evaluating that from 2 to 4. So you're really doing 6 plus 3 times 4 minus 3 times 2. Or the same as 6 plus 12 minus 6, which is just 12. Not super hard. You could even think about this geometrically or graphically, right? If I'm trying to find the integral from 2 to 4, well, from 2 to 4 of 3, just finding the area of this rectangle here, right, for that portion, which ends up being a base of 2 and a height of 3, so it's 6. You could do it that way also if that seems easier. I think taking the integral sometimes is a little more obvious to guys. But you should get 12, you should not get 9, you should not get 6. Again, this one's not super hard. It's pretty basic algebra stuff. You just got to really not fall for this like trick right here that it feels like just add 3 to it. Okay, any questions on this guy? I'm going over ones that like over half of you missed, by the way. And it might have been that you just didn't get to it. So this might be like, I never even saw this question. You just might not have gotten to it. Other questions? Any questions? All right, let's go on. I put the multiple choice options here because this one can be written in several different ways. When I first did this problem, I went down kind of an old route without looking at the multiple choice options. And then I got something that I know was right, but it wasn't on here. So that's a part of multiple choice that can be tricky. That's not true on the free response. On the free response, if you get an equivalent answer, you're fine, as long as it's equivalent. On multiple choice, you have to be able to get one of the answers provided. Okay, so this is implicit differentiation. We're given tangent of x plus y is equal to x. This is not a super hard implicit differentiation, except that some of you still struggle with your trig derivatives. So you need to make sure you go through those. So the derivative, we're taking it of each thing. The derivative of tangent of x plus y, this is where some of you struggled, is secant squared of the stuff, this is chain rule, of x plus y, and then I need to multiply by the derivative of the stuff. And some of you just multiplied by dy dx. You were like, well, the derivative of x is 1, so it's just dy dx that I'm multiplying by. No, the fact that the derivative of x is 1 matters. We're multiplying by 1 plus the derivative of y, which is dy dx. You actually need to multiply by that. Okay, so we have secant squared x plus y, that's the derivative of the outside. Then we have to multiply by the derivative of the inside for our chain rule, 1 plus dy dx. Then that's equal to 1. Some of you continue to set this up like dy dx is equal to, like you just start labeling on the left side. That's incorrect. We don't have a y equals, so our next line would not be dy dx equals. You're differentiating implicitly, meaning you don't have the dy dx set to one side already. You're just taking the derivative of all of the pieces. Okay, now what I did wrong, I'll be honest with you on this first one, I took this secant squared and I started distributing it. Because that's how like some of the quest ones worked, and that's how some of the ones I've seen before worked. That is not the right approach here. You get pretty stuck. All they did here to isolate the dy dx was divide over the secant squared. So they get 1 plus dy dx is equal to 1 over secant squared x plus y. And then subtract the 1. So we get dy dx is equal to 1 over secant squared x plus y minus 1. Ms. Toshner, that's not an option. Yes, it is. If you know your trig identities, the reciprocal identity, 1 over secant squared, is just the same as writing a cosine squared of x plus y minus 1. It's not wrong if you distributed that secant squared x plus y, like you could get to an answer where you have dy dx equals, but it's not an option. And so I went that route and was like, what? It's got to be one of these, and I know how to do this problem. So I went through and redid it. Still not very many steps to go back and redo. Okay. Questions on this problem? Some of you just saw ln and you were like, I don't know, ln seems like right. Seems like a scary problem. I'll just pick ln. I mean, whatever. It's not the worst choice I get. Well, it's, yeah, maybe it's the worst choice on this one, but it's fine. Okay, any questions? Oh boy. Okay, area of the region bounded by the lines x equals 1, y equals 0, and the curve y equals x times e to the x squared is. So we're trying to find the area of the region bounded. Area is just top minus bottom. This curve is not obvious how this curve looks, but it really just kind of looks like e to the x. It ends up going through the origin because it has an x times, but it's not super important you know that. There's only one curve here. So we don't have to really pick a top and a bottom curve. It tells us that we're bounded by x equals 1. X equals 1 is a vertical line over here at 1. Y equals 0. That's the x-axis. And then the curve x e to the x squared. Wherever that curve is, we know that that curve is positive. We can imagine it. Ends up looking like an e to the x curve. We're going to get something like this. Okay, that's our function x e to the x squared. Now you should know that that's going to intersect at 0 just because there's an x times, right? Like x times anything in factored form, you're going to have a 0 at 0. Like if it was x times x minus 1 or something like that. X times e to the x squared. If you plug in 0 for x, you're going to get a 0 there, right? So we should be setting up area equals, we should have an integral that goes from x equals 0 to x equals 1 of top minus bottom. Now our top function is x e to the x squared. What's our bottom function?
X equals 1.
Nope. That would be our right function, which is why we're using 1 as our right bound. So our top function is x e to the x squared. What's below that?
Sorry, y equals 0.
Y equals 0, exactly right. So this is our bottom function, is the y equals 0 portion. So we're subtracting 0, which means we don't really need to write that. So we just get a dx here. Hey, guess what, guys? It's more u sub. You need to know your u sub. Make sure you're doing your u sub. I hope I'm blowing out someone's headphones right now, screaming at you. U is equal to x squared. Almost always, if you've got an e raised to a something, that's probably your u. Not always, but a lot of the time. Some of you get really stressed out about e. It's not a hard integral if you know how to do your u sub. Okay, your du is 2x dx. I do not have a 2x dx. I have an x dx. So I'm going to divide over the 2. So I get 1/2 du is equal to x dx. I hope y'all are writing this down. Some of you are like just watching, just having a nice morning, just watching what I'm doing. I know how to do this. You guys need help on your u sub. Make sure you're taking good notes. We're going to reset up our integral. I'm going to have a 1/2 out in front. I'm going to have an e to the u du. So I've replaced everything inside of the integral so far. I now need to replace my bounds. And hey, the bounds are super easy to replace here because u is equal to x squared. So 0 squared is still 0, and 1 squared is still 1. So yes, we did change our bounds, but our u and our x bounds happen to be the same. Sometimes that will happen. Okay, some of you here, you just don't know what to do. You're like, I don't know, is this e to the 2u or e to the 2 or e squared over 2 or something like that? The integral of e to the u, as long as it's just a u up there, is just e to the u. Okay, it's like the derivative of e to the x is just e to the x. If there's something else up there, right, if it's e to the 5x, then it works differently. But just e to the u is e to the u. So we get 1/2 e to the u from 0 to 1, which is 1/2 e to the 1 minus 1/2 e to the 0. A lot of you get very, very comfortable with like when that bottom bound is 0, you stop thinking about it and stop plugging it in. You have to be careful on this problem because e to the 0 is not the same as like 0 squared. It doesn't just go away. You don't get a 0, right? E to the 0 is technically 1. So we have 1/2 e minus 1/2. And I think the way that they wrote this final answer was like e minus 1 over 2. Questions on this problem? In all honesty, this is one of the easier area between curve questions. So some of you, I think you just thought it would be a long question. Maybe you skipped it for that reason. You saw the U sub or you saw the E. You were like, I have no idea how to start this. That's good test taking strategy. If you're not good at this, yeah, skip it. But my goal is for you to be good at all of them so you feel confident attacking every single question. What questions do you have on this one? No preguntas? Okay, number 7. The function f is continuous at x equals 1. That's a statement, not a question. Tells us it is continuous. Okay, and it says if f of x is equal to, I would take a second and copy this down. We've got a piecewise function. We've got continuity, which is our definition of continuity. We've got lots of radicals and what looks like a very crazy equation. And then what you guys will come to hate is this like random letter k. They love throwing this random letter k for constant in at you guys on all through the AP test. It shows up quite a bit. A lot of guys, anytime they see a k, they just have PTSD and they're like, nah, I don't know, I'll just move on from this one. So this one's not that bad, but again, more than half of you missed it. So I want to make sure I'm going over it. So we're given this function. It tells us when x does not equal 1, meaning the whole graph except for one little point, when x is equal to 1, the whole graph is equal to that equation. Square root of x plus 3 minus square root of 3x plus 1 over x minus 1. The whole graph is equal to that. Left, right, everywhere else. At 1, it's equal to k. If it's continuous, we have to go back to our definition of continuity, and you should remember that the limit of f of x as x approaches 1 from the left or the right, that produces the limit, is equal to f of 1. That's our definition of continuity. Usually I break that up into 3 parts, like the limit of f of x as x approaches 1 from the left is equal to the limit of f of x as x approaches 1 to the right is equal to f of 1, the value at the point. Okay, and I'm using 1 here because that's the place where our function could break apart according to this piecewise. Okay, well, in order to find the value of k, which is f of 1, right? F of 1 is equal to k. I need to figure out the limit as we approach 1. And the limit as we approach 1 means that I'm finding the limit as x approaches 1 of that top function, square root of x plus 3 minus rad 3x plus 1 all over x minus 1. We should always at least think through what would happen if we plugged it in. Sometimes you plug it in and it just works. So always think through that before you start doing all this other stuff. But if I plug in 1 here, I get the square root of 4, which is 2, minus the square root of 4, which is 2. So 2 minus 2 over 1 minus 1. So I get 0 over 0. That tells me there's a hole at 1, meaning at some place, if I do some algebra, I'm going to be able to cross out x minus 1 over x minus 1. That's going to happen. Okay. The approach here is basically the only approach we know how to deal with a problem like this. What would I have to do in order to simplify this limit?
Multiply by the conjugate.
Exactly right, George. We're going to multiply by the conjugate. So we're going to multiply by square root of x plus 3 plus, remember the conjugate, the sign changes between those things. Nothing changes inside of those square roots, just the sign in between them, over plus square root of 3x plus 1 over exactly the same thing. So square root of x plus 3 plus square root of 3x plus 1. It is not helpful to distribute the denominator because I know there's a hole at 1. I'm trying to eventually cross out x minus 1 over x minus 1. So I'm going to get equals the limit as x approaches 1. I'm going to leave the bottom as parentheses x minus 1 times that whole other garbage thing, square root of x plus 3 plus square root of x, square root of 3x plus 1. And now the numerator is what I want to simplify. I do want to FOIL the numerator, but remember, since it's the conjugate, you're not really doing first, outside, inside, last. You're just doing first and last because the OI part of the FOIL is going to cancel out because of our conjugates. So I'm doing x plus 3 times x plus 3. Excuse me. I'm doing square root of x plus 3 times square root of x plus 3, which is just x plus 3. And then I'm doing square root of 3x plus 1 times square root of 3x plus 1, which is just 3x plus 1. But there's a minus here being multiplied by a plus. So I'm going to have minus 3x and minus 1, right? I really have minus 3x minus 1. Questions on this so far? So it looks like we don't get a 1. You're like, 3 minus 1 is 2, Miss Toshner, and minus 3x and x, that's not x either. So what we actually get here, if we simplify that numerator, is x minus 3x, which is negative 2x, and then plus 3 and minus 1, which is a plus 2. Right? All over that same stuff. Remember, we're trying to get an x minus 1. So I'm going to factor out that negative 2 before I rewrite this whole thing. I'm going to factor out that negative 2. So I have an x minus 1 left. And now I'm going to be able to cancel that out. If I got a 0 over 0, I've got to be able to cancel that out. So I've got to be able to do something to cancel that out. Okay, and in this case, that was the conjugate. Now I can cancel it out. Once you cancel it out, now you can plug in your 1. So we're going to get equals negative 2 over the square root of 4. So we're plugging in a 1 there, plus the square root of 4. Because again, we're plugging in a 1 there. We get negative 2 over 2 plus 2, which is negative 2 over 4, or negative 1/2. That's the limit. That means that's the y value we're approaching. So in order for it to be continuous, that k value has to be equal to negative 1/2. What questions do you guys have on this one?
On the Princeton review, I think there was some, it didn't really have like k as the second function. I think in these types of problems, do you just set them equal to each other and try to solve, or is that something else?
Got to be careful of that. Sometimes that doesn't work. And this kind of a question is showing up more and more on free response. And on free response, you have to label things correctly. And I know, yeah, or your final doesn't really require free response. So like most guys, what they'll do is they'll set the two things equal and then it won't work. And then you won't get any credit. But on a free response question, they're looking for you to label it with like a limit, or they're looking for you to label it with like an f of 1 or something like that. And so I would just get in the practice of doing that. Sometimes that works. If you're thinking about the definition of the derivative, that process will always work, because sometimes there's more than one and it's like a less than and a greater than. And so you need to be writing like the limit of f of x as x approaches 1 from the right equals, and the limit of f, like sometimes you have to do that step. We just only had we only had one limit because it was the same from both sides. But yeah, your process, that works sometimes. I'll say that. Okay. All right, guys, it's 8:48. We're not going to get into another question, so I'm going to call time here right now. We have class tomorrow. I have, I think, 3 or 4 more questions to go through from your exam too. So I don't think it'll take the whole class. Again, go through whichever ones you missed. I would encourage you to work with each other. Princeton review this week is optional. No place to turn it in. Just do it if you think that will help you. If you don't think it'll help you, do something else. Make sure you're doing something over these next couple weeks when I'm out. And you can lean on each other and you can lean on Mr. Aston. for help if you need it, or any of the guys that have already taken calculus. So BC guys or guys that are in that like advanced math class.